Hello, welcome to this lesson. In today's class, we'll be talking about motion, kinematic in physics, which involve motion. This is the lesson 1. Please watch out for lesson 2 and as well lesson 3 and so on, right? Good. Now, motion and kinematic. First of all, before we proceed, we'll continue. Please subscribe, like, and also share. And also hit up the notification bell so that at any time we uploaded any video, you get notified. Now, motion and kinematic, you have to understand these formulas, which are V is equals to what? U plus AT, the first formula. This is the first formula. Second, and S is equals to half upon what? U plus V all bracket T. You have to understand this is the second formula that you have to know. Also, V square is equals to U square plus 2AS. And the last one, which is what? UT plus 1 upon 2 AT square. Take note of these 4 formulas. If you want to know motion, kinematic, lesson 1, right? Take note of these 4 formulas. Good. These are the formula that you have to understand. Now, in this area, this formula, we normally use this formula for horizontal movement. Anytime an object or a particle, the motion that is occurring with that object or particles is horizontal movement, automatically you think about what? These formulas, right? Good. Take notes. You get it? Or a uniform acceleration. Anytime you a motion takes place that is horizontal movement and as well a uniform acceleration, these are the formula that you have to think about. If it is a vertical acceleration, if there is a motion that takes place and the motion is a vertical, automatically these are not the formulas. We will deal with that in another lesson, right? So lesson 1 will be talking about what? Horizontal movement, right? That involve uniform acceleration. Take note of what I have just explained. Good. Now let's try to see how we understand these various letters that are there. These are their symbols. Where U is called as the initial velocity, V is called the final velocity, S is the displacement or distance covered, right? T is the time taken by the object or the particle. A is acceleration. So these are the meaning of the letters that you are seeing here. V is the final, U is the initial, A is acceleration, T is the time taken. Is it clear? Please take notes. And please also subscribe. Don't forget, always subscribe in this now. If you are new here, please subscribe and also like and always share my video. That's one of the ways you can help me, right? Good. So that's the first thing you have to note. Understanding the symbols and the letters that are there, what they mean. Also, now let's talk about what? Their units, right? Understanding the various units is very more important. You get it? So for U and V, of course, U is called the initial velocity. The symbol or the unit for U is what? Meters per seconds. Do you see? Meters per seconds or meters per seconds. You can write it anywhere, any of this way. That's the unit. Anytime you see meters per seconds, it talks about velocity, right? V is what? Meters per seconds as well or meters per seconds. Do you see? Good. Take note always. We come for what? A. A is what? Meters per second square or meters per second. So anyway you write it this way, you are correct, right? So anytime you see meters per second square, it talks about acceleration. S is what? Meter. It talks about distance. T is what? Seconds. You see? So these are the various units which you have to pay special attention as you be reading any given question in kinematic that involve horizontal movement with a constant what? Acceleration, right? Or uniform acceleration. You get it? When they say constant acceleration, it means the acceleration is not increasing, it's not decreasing. It's in a uniform way. It's in a steady way, right? Good. I hope it's understandable. That's what you must first understand. Now let me just give you brief tips or brief things that you have to understand as well before we dive into question solving. We say note, if a particle moves from rest, the initial velocity is always 0. So anytime a particle moves from rest, take note of this word, from rest, automatically initial velocity is 0. If a particle come to rest, take note of this, come to rest, final velocity is 0. So anytime a particle, right, move from rest, as you see from rest, so u is equals to 0. You see? Now if you see a particle says come from rest, automatically come to rest, automatically v is equals to what? 0. Take note of these things that I've just explained when you be seeing them in a question, how you are going to interpret it, right? This is very key and it's very more important. Now let us dive into example solving. This is example 1. A car accelerates uniformly from rest. Do you see? From rest, automatically u is 0. From rest, you see what I was explaining? Anytime you see from rest, is 0. At 7 meters per second square, what is the velocity after 5 seconds? They ask you for what? The velocity after 5 seconds. Now let's go. From rest, automatically u is 0. Initial velocity is 0. Now, at 7 meters per second, automatically this tells you that this is the acceleration, because the symbol or the unit for acceleration is what? Meters per second. At times they will not tell you that is the acceleration, but the unit itself will tell you that is the acceleration, right? So good. We say what? Acceleration, which is a, is equals to what? 7 meters per second square. You see it? What is the velocity after 5 seconds? So they ask you for velocity. You don't know, right? We say what? After 5 seconds, the time is what? 5 seconds, SEC. But the time is what? 5 seconds. Is this it? Now what are we going to do? Now we are going to write our formulas, which are what? V is equals to u plus at. Okay, let me just put them here. Okay, u plus at. These are formulas, right? See, we are going to, which formula we are going to use here? The formula that best fits. That's the formula we are going to use. See, this first formula says we have v, we have it. U, we have u, which is equals to 0. We have a, and as well we have t, and we are supposed to find v. You see, automatically we are going to use this formula. But for this second formula, there is no s here in the data. This, it has s, there is no s. This other one as well, it has s, there is no s. So these three formula are not fit. Is this first formula. So we say v is equals to u plus at. You see the procedure, please. Always these are the procedure where you are solving motion involved. Motion, right? Good. Now we go. What is v? It's v that we are supposed to find. What is u? U is equals to 0 plus. What is a? Is 7. What is t? T is 5 seconds. So v is equals to what? Right? We say what? 7 times 5. Which give you what? If you use your calculator, 35. So 35 what? Meters per second. Per second. That's the final velocity. Do you see it? I hope it's clear. If you don't understand, please replay again the video and concentrate on my explanation, right? The explanation has a lot to help you to understand this topic. Please subscribe, don't forget, like and also share. Now we move to example 2. An object moving with velocity 50 meters per second to accelerate at 2 meters per second square for 5 seconds. Calculate the final velocity. Do you see? There is no what? Look at the symbol. From rest or to rest. It's not here. Good. Automatically they say final velocity. Now we write our solution. An object moves with a what? Velocity. So this talks about the initial velocity, which is u is equals to what? 15 meters per second, right? Accelerate at 2 meters per second square. So you see, acceleration is a 2 meters per second square. You see, for 5 seconds, do you see that is time? The unit for time is what? Seconds. So t is equals to what? 5 sec. Do you see it? Good. Now calculate the final velocity. What is the final velocity? Is v. V is equals to what? We don't know. That's what we asked. Now let us bring our formula and see the best fitting formula. Is that formula that we'll be using. These are the procedure. Now let's see. There's u here, u. A, there's a here. T, there's t, and as well v. There's no s. There's this formula has s, but there's no s here. This formula, do you see? This is the procedure. As well, this one has s, right? But there's no s. So if we knock out these three formula, we take the first one because that's the best fitting formula. You get it? Which is what? V is equals to u plus at. Do you see it? What is v? It's v that we are supposed to find. What is u? Is 15, the initial velocity, plus what is a? Is 2. What is t? Is 5. So v is equals to 50 plus 2 times 5, 10. So v is equals to what? 25 meters per second. Do you see? That's the answer. Right? So the object is moving. Okay. The object has a final velocity that's what? 25 meters per second. Is it understandable? Good. So please, if you don't understand, you play the video. And also don't forget to subscribe. Don't forget to like. Don't forget to share. Don't forget to hit up the notification bell. Okay? If you have any doubts, let me know in the comment box. If possible, I will give you my private line so that we discuss. I'll help you to clear out your doubt. Right? Good. We proceed to the next example. Example 3 says, a particle starts with velocity 3 meters per second. You see? And accelerates to at 0.5 meters per second. What is its velocity after 10 seconds? And how far has it traveled? How far means what? They are asking you to the distance. For the distance. That means it involves total distance. So anytime you see how far, it talks about distance. Right? Good. Now we collect our data. A particle starts with a velocity of what? The starting velocity is always called what? The initial velocity, which is what? U. So u is what? 3 meters per second. And accelerates 0.5. So acceleration is equals to what? 0.5 meters per second square. Do you see the acceleration? What its velocity after 10 seconds? So they ask you, what is the velocity after 10 seconds? So velocity, what is the velocity after 10 seconds? Do you see? Good. And how far has it traveled? So they ask you for the distance. You don't know. So they ask you for two things. What is the velocity after 10 seconds? And how far has it traveled after the 10 seconds? That's what they ask you. But what are we going to first do? Let us first collect our data. See. This is our data. Let us watch the first good formula. We have u, initial velocity, a, and t, we are supposed to find v. So you use this first formula, right? We are about to find first v because they ask you the velocity after 10 seconds, right? So use this first formula. V is equals to u plus at. Do you see? We have v. We are supposed to find v, velocity after 10 seconds. Initial velocity is what? 3 plus. What is the acceleration? Is 0.5. What is the time? Is 10 seconds. The velocity after 10 seconds. V is equals to 3 plus 0.5 times 10 is what? 5. So 5 plus 3 is what? 8 meters per second. So the velocity after 10 seconds is what? 8 meters per second. You see? Now the question says what? How far has it traveled in this same time, which is what? 10 meters per second. You see? Now we have now what? We are coming out to find what? The other one. Right? Now we have u, a, and what? T, which is the time, and s. We watch u, a, s, but we don't have their t, so we are not going to use this formula. You see, we are not going to use this. Right? Here there is no s, we are not going to use this. See again, here there is no a, we are not going to use this. So which formula we are going to use? Is this one we are going to use, because we are about to find a. Right? Good. Sorry, S. Here there's what? There's U, there's T, there's A. Huh? Good. So we go. So the distance equals to what? UT plus 1 upon 2 AT square. Please, if you don't understand, replay the video. I believe you understand more precisely. And also focus on my explanation. We are about to find S, the distance. What is U? The initial velocity is 3. What is the time? It's 10 seconds plus 1 upon 2. What is acceleration? 0.5. What is the time again? T is 10 seconds square. Do you see? It has square. Right? Good. I hope it's understandable. Now we go. We say S is equals to what? 3 times 10 is 30 plus 1 upon 2. 0.5 into 10 square is what? 100. Right? So S is equals to 30 plus 1 upon 2. 0.5 times 10. 0.5 times 100 is what? 50 if you use your calculator. S equals to 30 plus 1 upon 2 divided by 50 is what? So 1 upon 2 times 50 is just 25. 1 times 50 is 50. 50 divided by 2 is 25. So S is equals to 30 plus 25 is what? 55 what? Meter. This is the total distance covered in the what? In 10 seconds. That the car covered in 10 seconds. Is it understandable? Please, if you don't understand, you play the video. I believe you understand more precisely, and everything will be simple. Everything will be in simplicity for you. Right? Thank you very much. Now we proceed. Now we move to example 4. A particle traveling with acceleration of 0.75 meters per second pass a point O with speed 5 meters per second. How long will it take to cover a distance of 250 meters? What will its speed be at that time? You see, the question say, what will its speed be at that time? Right? Now let us collect our data. A particle accelerates what? 0.5 meters per second. So say acceleration 0.75 meters per second square. You see, that's acceleration. Passes at a point O. So this point O means that is the initial position, right, of the particle movement with a speed of what? 5 meters per second. So automatically this is what? Initial velocity. U is equals to 5 meters per second. How long will it take to cover a distance? How long? Take note of the word. If you see how far, it talks about distance. If you see how long, it talks about time. Right? Good. So how long will it take to cover a distance? So time, they ask you for the time. We don't know. At this time, how long will it take to cover what? A distance of what? S, which is the distance of what? 250 meter. Right? What will its speed be at that time? So at this time, at this distance 250, how long will the particle take to travel from point O, which is the starting, to what? To this time, to this distance? And also, what will be the speed of at this particular distance? That's what the question is saying. So we say what? V is equals to, we don't know. So let's talk about the final velocity. That this final velocity means that the ending velocity that what the car is having at this particular distance. Right? Good. Now we go. We bring our formulas. Right? And kinematic, all about kinematic, is the question that will determine which formula you are supposed to use. That's what all you should understand about it. Now let's go. Now we are solving first for T, the time. We have A, we have U, S, and T. So let's see which best fits. Okay, it's not V we are finding, so automatically this one is void. We have S, we have U, we have T, we have A. So this is the best fitting what? Formula we are going to use. So S is equals to what? UT plus 1 upon 2 AT square. You see? So that's the formula. We're not going to use here, there is no S. Good. Here there is no what? A. Good. So now we go. What is S? S is 250. 250 is equals to, what is U? U is equals to 5. What is T? T we don't know, is T we are about to find, right? Plus 1 upon 2. What is A? A is 0.75 upon what? T square is T we are about to find. 250 is equals to what? 5T plus 1 upon 2 into what? 0.75 T square. You see where you multiply them, right? We say 250 is equals to what? 5T plus 1 times 0.75 T square is what? 0.75 T square divided by 2. Right? What are we going to do? Get denominator of 1. So 250, find the LCM. What is the LCM? Is 2. 1 into 2 times 5T is what? 10T plus 2 into itself 1 times 0.75 is what? 0.75 T square. What are we going to do? Get denominator of 1, from there we cross multiply. You see, we multiply this, multiply by this, and this denominator multiply by this numerator. So 250 times 2 is what? 500, right? Good. Equals to 10T plus 0.75 T square. Do you see it? Is it understandable? Now we say, see, this is a what? It's a decimal. Please, if you don't know how to solve decimal, go and watch my video on exponential equation. I precisely explain on it how to convert. Now we are supposed to come and convert this decimal to fraction. How we can convert it? We say 500 is equals to 10T plus, we can convert this decimal as what? 3 upon 4, right? T square, right? 3 upon 4 is the same as 0.75, right? 3 divided by 4, 0.75. And what are we going to do? We are going to say 3 upon 4 T square plus 10T minus what? 500 equals to 0. Now we have transposed this 500. You see it? Now what are we going to do? We are coming to what? Remove the denominator, which is 4. Get denominator of 1, denominator of 1. So we say what? We say 3T square plus 1 into 4, 4 times. Right? 4 times 10 is what? 40T minus, good, and 1 into 4, 4 times. 4 times 500 is what? 4 times 500 is 2000. Is equals to 4 times 0 is just 0. You see, now we have a quadratic equation. Now what are we going to do? Let's try to divide both sides by 3. This is not going to work. So we are going to use quadratic equation by using the formula method, which is what? T is equals to minus b plus or minus the root of what? B square minus 4ac. Right? Good. We are supposed to find b. What is b? So we are a is equals to 3, b is equals to 40, and c is equals to minus 2000. Right? Now we go. T is equals to minus, what is b? B is 40, right? Plus or minus the root of what? What is here is what? B square, 40 square, right? Minus 4, what is a? A is 3, minus 2000. Do you see it? Good. Minus 2000. Good. So say T is equals to minus 40 plus or minus the root of what? 40 square is what? 1600. 1600. Right? Minus. So minus times minus is plus. Do you see? Good. So we say 2000 times 3 times 4 is what? 24,000. Good. So plus 600 minus, okay, plus 1600 if we use our calculator, plus 1600. Good. So T is equals to minus 40 plus or minus the root of what? 25,600. Right? So T is equals to the root of 25,600. Now let's see. The root of 25,600. It give you minus 40 plus or minus the root of 25,600 give you 160. So what next? So say t is equals to minus 40 plus 160. Here say what? T is equals to minus 40 plus minus 160. So t is equals to what? Minus 40 minus 160 is what? 120. Right? T is equals to 120. T is equals to where? What? Minus 200. Right? Good. Minus 200. Now we say therefore the value of t dot t are what? 120 and minus 200. This is your answer. Use the value of t. So now what is the time? Time will never be negative. Right? So the question say what? See the question. What will its speed be at that time? Sorry, yes. Yeah, what is the time? Time will never be distance. So say therefore the time is equals to what? 120 seconds. Good. That is the time. We just find for the time. Now we come to find for what? For v, velocity. Good. Now we bring our formula. These are our formulas. Now this were the data that we collected. Right? Now we have what? U, A, U, S, where? S is equals to, we have U, we have V, we have what? Time. But let's see. We are supposed to find V, the speed. We have U, we have A, we have S. So we are going to use this formula. You get it? Good. So we are going to use V square is equals to U square plus 2AS. Right? Good. What is A? What is V? Is V that we are finding. V square is equals to, what is U? U is 5 square plus 2. What is A? A is 0.75. What is S? S is what? 250 meter. So final velocity is equals to what? 25 plus 2 times 0.75. 2 times 0.75. It gives you what? 1.5. 1.5 multiplied to 250 times 2 what? 250. 250. It gives you 375. So final velocity is equals to 25 plus 375. Right? So V square is equals to plus 25. 250 plus 25 give you 400. You see? So the final velocity is equals to the square root of 400. Right? Square root of 400. It gives you 20 meters per second. You see the final velocity? That's 20 meters per second. Please, if you don't understand, replay again the video. Right? Thank you very much. Don't forget to subscribe and like, share this video. Thank you for your time with me.